Okay, so if we were to take the limit of this, hey, over there, quiet. Here's what happens. If I plug this in, and I say sine of 0 all over 0, I get 0 over 0, which won't work. Now there's a special rule, and I'm not going to explain the whole rule to you today, but the special rule is called L'Hopital, not La Hospital. But L'Hopital's rule is what we would use, and it's going to be a while before we cover it, but in some of our homework problems, this is always going to equal 1, not 0 over 0, and I'll show you how in a minute. But L'Hopital's rule is basically if I take the limit of a function, right, as x approaches some value for c, and I get 0 over 0 as one of the answers. L'Hopital rule is basically I can take the derivatives of the top and bottom. And we'll do a more formal explanation of all this later on down the road, but since you guys asked, I wanted you to know this. So what I would do is I get to this point where the limit of this as x approaches 0 is going to end up equaling 0 over 0. So that qualifies for L'Hopital's rule. And so what I could do then is I could say that that would be the same as the limit of cosine, because cosine is the derivative of sine. You guys don't know that yet, but it is. And then the derivative of x is just 1. Okay? And so now if I were to plug that in, I get cosine of x, or of 0, which is just 1. So we went through all that to say that x, as x approaches 0, of sine of x over x, it's 1. And you're just going to have to memorize this for now until we actually have the chance to cover L'Hopital's rule. This is a pretty well-known limit that we use a lot in calculus. I am a little surprised that your textbook does it in like the second chapter without defining what it is, but that's where that value comes from. Okay?
Interesting.
Any questions?